Perimeter problems begin on page 187, and we're reminded before we begin example 4 to recall the formula for the perimeter of a rectangle. The perimeter of a rectangle can be found with this formula, 2 times L plus 2 times W. That's because a rectangle with length L and width W has a perimeter found by adding up all four sides. That'll be the length plus the length again, plus the width again. And L plus W plus W, combining like terms, is 2L plus 2W. That's how you find the perimeter of a rectangle. Now looking at example 4, the length of a rectangle is 5 inches more than twice the width. If I translate that sentence into a mathematical expression, I get the length of a rectangle, L, means equals 5 inches more than something. What's the something it's 5 inches more than? Twice the width. Twice means 2 times the width. So for this rectangle, L and W, this L is equal to 2 times the width plus 5. In other words, instead of writing L, I can write this. We also know the formula for the perimeter of a rectangle. Perimeter equals 2L plus 2W. We have two variables here, L and W, and the same two variables here, L and W. We have a third variable here. But we're also told that the perimeter is 34 inches, so we actually know the value of P here. Let's replace P with 34. Now, I have two sentences and two variables, L and W. And L, it turns out, has a value of 2W plus 5. So I can also take the L out and replace it with 2W plus 5. Let's rewrite this statement. 34 equals 2L plus 2W, but let's not write the L as L. Let's write it the other way we can write L. Let's write it as 2W plus 5. I've substituted for L the value of L, the other way of writing L. Now that I've done that, I have an algebraic equation that I can solve, and it only has one variable in it. Using distribution first to get rid of my parentheses, I can rewrite this equation as 34 equals 2 times 2W plus 2 times 5 plus 2W. Combining like terms, I get 34 equals 6W plus 10. Let me just rewrite that line so that we can carry on. We want our variable by itself. We've said in the past that we want the variable on the left, but it doesn't have to be, as long as it's only on one side and not the other. The fact that I have 10 added to the variable term means that it's in my way, so let's get rid of it by subtracting 10 from this side, which of course means I must also subtract it from the other side. Now my equation reads 24 equals 6W. Finally, I can multiply both sides by 1/6 or divide both sides by 6. 4 equals W. The width of this rectangle is 4, but we're asked to find the length and the width. My original sentence that the length is 5 more than twice the width, well, now that I know the width, I can replace W with 4 and rewrite the other equation. Length equals 2 times W, 2 times 4, plus 5. 2 times 4 is 8, and 8 plus 5 is 13. So the width of this rectangle is 4 inches, and the length is 13 inches. You can use any variables you like. Your textbook uses x, and it also uses a different approach to solving the problem. So it doesn't end up with 2 sentences, just the one, and it does the substitution without really explaining that that's what's happening. You could use x and y here, but then you'd have to use x and y in your formula for perimeter as well. That's absolutely fine. I used L and W because it helps me keep straight what I'm actually talking about. Remember that a variable is just a letter standing for a number. I wanted to remember as I was working through the problem that the variable I chose for length meant the length. If I used x, I might forget which one it was, length or width. So choice of variable is a very personal thing. Use whatever works for you. I used L and W just because it helps me remember which variable stands for which value.